This is Metadataset. Metadataset is a website at www.metadataset.com. Metadataset gives you open access to the data and metadata that we've extracted from scientific publications. These publications are about the effects of interventions. Examples of interventions include agricultural and environmental management practices, such as planting crops in polycultures and eradicating invasive plants. These interventions have different effects on different outcomes. Examples of outcomes include agricultural outcomes, such as crop yield, and environmental outcomes, such as biodiversity and soil carbon. The data on Metadataset are about the effects of interventions on outcomes, and the metadata are about where and how these effects were tested. So using the metadata, you can filter and weigh the global evidence to find evidence that's relevant to your local conditions. Metadataset is a work in progress, but in this video I'll show you two ways that you can use Metadataset now. The first way is that you can use it to find scientific publications that are relevant to you by browsing an evidence map. And the second way is that you can use it to find out the effects of an intervention based only on the evidence that's relevant to you. For example, evidence from your country. This second way of using Metadataset is a proof of concept for a method that we call dynamic meta-analysis, and I'll show you that later. But first I'll show you how to find relevant publications. These are the subjects that are available on Metadataset now, and if you click on one of these subjects, you'll see links for browsing publications by intervention or by outcome. And if you click on one of those links, you'll see a hierarchical classification of interventions or outcomes. So you can click here to expand all of the interventions. You can click here to collapse all of the interventions. The default is to only show interventions for which we found publications for this subject, but you can click here to show all interventions, whether or not we found publications. So perhaps you're interested in all publications on crop management, in which case you could click here and it would include publications on any of these interventions. Or perhaps you're only interested in publications on intercropping or polyculture versus control, in which case you could perhaps click on this link here. And that would show you that we found 216 publications on this subject, cassava, and on this intervention, intercropping polyculture versus control. There is an evidence map that shows you the number of publications we found for each country. So here there were 70 publications from Nigeria, but note that not all publications provide locations. You could click on one of these countries, or you could click on this link here to see those publications, or you could filter by outcome, and these outcomes are also hierarchical, so perhaps you're only interested in effects on crop yield, and so you could click here to see that there are 163 publications that we found that were on intercropping polyculture and also on crop yield for cassava. So you could click on one of these countries here now to see those publications. Here's the list of publications with the titles and the authors and other bibliographic information. And if a DOI is available, then that will be shown here, and you can click that to access the publication, or you may have to try to find it through Google or Google Scholar. So that's the first way of using Metadataset, and the second way is dynamic meta-analysis. If you click on cover crops, you'll see that there are links not only for browsing publications, but also for browsing data by intervention or outcome. Perhaps you're interested in the effects of cover crops on crop yield, and you can filter that outcome by intervention, and you can see that there are 316 data points for this outcome, and you can see a map of data for this outcome, and you can filter by intervention. If you select rotating cash food crops with cover crops, you can start the Shiny app that allows you to do dynamic meta-analysis, and it may take a moment to load. There are two analyses that you can do. The first is subgroup analysis, and the second is meta-regression. And we suggest that you do both, but we suggest that you do subgroup analysis first because it's faster and simpler. I won't talk about all the settings, but for this example we will not exclude outliers, so I'll deselect this option. And then we'll click Start Your Analysis. And you'll see the results in terms of the response ratio. And the response ratio is the outcome with the treatment divided by the outcome without the treatment. So a response ratio of 1 means that the outcome was exactly the same with the treatment or without the treatment. And the text here explains that this outcome was 0% different with this intervention than it was without it, which is a response ratio of 1. And this effect was not statistically significant with a p-value of 0.9788. Your data and all data are the same here because we have not yet selected any filters, but we'll do that next. Perhaps you're only interested in cover crops that are brassicas, and so you select that from the filter for cover crop type. And perhaps you're only interested in studies from the United States, and so you select that. And perhaps you're only interested in cash crops that are irrigated, and so you select that. You then click Update Your Analysis. If there are studies for those filters, then you'll see a subgroup analysis. You'll see the results for your data compared to the results for all data. For your data, this outcome was 13% lower with this intervention than it was without it, and that's a response ratio of 0.87. And this effect was not statistically significant. It was not significantly different from a response ratio of 1, as indicated by this confidence interval that crosses the dotted line that represents 1. This subgroup analysis included 14 data points from 2 publications. After you do a subgroup analysis, you can do a meta-regression. Meta-regression is potentially more powerful statistically than subgroup analysis, but it's also more complicated and potentially much slower, so we recommend that you do it only after you've finished your subgroup analysis and only with the same filters and settings. The Shiny app has a cache, and if somebody has already done exactly the analysis you're doing, then there may be cached results, which we have here, so the results are much faster to load. You can see that the results of the meta-regression are also negative. For your data, this outcome was 9% lower with this intervention than it was without it. But now the results are statistically significant. You can see that the confidence interval for the meta-regression does not cross the dotted line that represents a response ratio of 1, whereas the subgroup analysis has a confidence interval that does cross that dotted line. There's also a warning saying that irrigated cash crop did not have a significant effect on this outcome, and you could consider removing this filter from your subgroup analysis. I won't go into the details, but if you're interested, you can look at the Model Summaries tab, and this will show you the meta-regression model that was fit. And the moderators that were included in this model were country and cover crop type, but not irrigated cash crop. You can also see a forest plot for your subgroup analysis and a funnel plot for your subgroup analysis. Based on that warning, you might decide that you want to deselect the filter for irrigated cash crop and update your analysis. And you can see that the subgroup analysis includes 30 data points from 3 publications. So by deselecting that filter, we added a publication to the subgroup analysis. You've now seen subgroup analysis and meta-regression, but I want to talk about another method called recalibration. If you click on the Study Summaries and Weights tab, you'll see summaries of the 3 publications that were included in the subgroup analysis. And for each of these publications, there's a slider for its relevance weight. The default is 1, but perhaps you read this paragraph and you decide that tomato fields are not as relevant to you, so you downweight this study. The others have a weight of 1, but this now has a weight of 0.5. And you go back to the meta-analysis tab and you update your analysis. You'll see that the results will change again because they're now recalibrated. They're now based on those relevance weights that you've specified. Finally, you can try different combinations and permutations of the settings as a method of sensitivity analysis. There are many assumptions that we need to make when we are doing a meta-analysis, such as how to handle missing or poorly reported data, and it can give you some additional confidence in the results if you can change these assumptions and still get similar results. And dynamic meta-analysis makes it relatively easy to change those assumptions and update your analysis. In this video, I've shown how you can use Metadataset to browse publications and data by intervention and outcome in order to find evidence that's relevant to you. I've also shown how you can use Metadataset to do dynamic meta-analysis of your selected data using subgroup analysis, meta-regression, recalibration, and sensitivity analysis. Thanks for watching.